right. Let's continue with Shige Maruyama and his talk on the magnitude 9.0 Tohoku Earthquake and Tsunami, a new interpretation.
Okay. I'm a kind of invader into seismological experts, and my title is Tohoku Earthquake and Tsunami could be explained by the other way around, but somebody already mentioned, so therefore not really new. This is the contents of what I would like to say today. First, after my self-introduction, and I will say 1, 2, 3, 4, 5. I'm a typical field geologist in Japan, and I worked on land geology, first in Japan. And afterward, I moved to United States and worked in California, and I met him at Stanford. But then thereafter, I started to work at Tectonics of Asia in a global scale, and to discuss supercontinent and others, and now geology of the Earth, back to the Akim. Then I started gradually feel some concept in seismology may be wrong. So this is my motivation for today. First, general interpretation for the Tohoku earthquake. Okay, that doesn't work, right? Do you have any better laser pointer now? Okay. Okay. Just above figure show the descending Pacific slab being contact with hanging wall from A to A dash by subduction. And that below, that region is seal regions. Figure B below showed sudden rebound upward. So earthquakes called tsunami. That's, you can imagine easily, right? So the new interpretation, origin of tsunami could be huge submarine slide. Underneath a huge sedimentary basins. I didn't show that, but I will show the next figure. The concept of asperity could be wrong, probably the opposite, the other way around. So gravitational energy release usually never trigger big earthquakes, probably instead silent earthquakes or just creep. So due to ubiquitous occurrence of dehydrated fluids. So conversely, big earthquakes occur along fluid poor or absent region. Key word is spray fault. So first, let me show this figure for the Tohoku earthquakes. So this is a so-called Benioff plane on the top of descending Pacific plate. So A, C, this one is called spray fault. It's active, observed long time before along northeast Japan. So D, topographic high. This is important point. Eastern margin of sedimentary basin here. So this basin is gravitationally unstable because every year huge sediments are coming to accumulate. So this is an important point through time if we consider tsunami. So next one, this one, is another important key figure. Please concentrate to listen. So A is a hanging wall, lithosphere. C is a Pacific descending slab, Pacific. So the B, small triangular regions cut on the top by the tangential line of top of Pacific slab. So this is the origin of spray fault. B behaves sometimes together with descending Pacific slab C. If this coupling is so strong. But sometimes they behave opposite. And then this is an important plate boundary barrier, just called physical boundary. And different from trench, this is material boundary. Material boundary. And also, please remind very recent progress of accretionary compress or accretionary wedge. Instead, almost all subduction zones, marine geophysics discovered, being destroyed, in front particularly. So the tectonic erosion commonly occurs at consuming plate boundary and nearly absent and the formation, no formation of accretionary complex, sediment subduction by tectonic erosion. In some good examples shown on land geology, we can see the big boundary of sedimentation. We call this is serpentinite melange belts, extending sometimes several hundred kilometers. And we see sedimentation age above and below. That's a huge, sometimes 200 to 300 million years gap. So the various huge sedimentary basins develops between an earth trench gap. You can just rotate it 90 degrees. So this way is north, Hokkaido, northeast Japan. You will see this is very unusual geography. All rains in northeast Japan transport weathered sediments. This river called Kitakami, this is Sendai. Also from the south, Abukuma, another river, transport all sediment into huge sedimentary basins here. This is a sedimentary basin. This is different in southwest Japan. So this is first important point. And along this cross section, you will see a trench slope break sometimes. Why? The reason why is tectonic extrusion of materials along a spray fault to make a barrier, just rock barrier. That is the reason why the sedimentary basin is formed in this region. Please note the distribution of spray fault underneath sometimes. This is the center of that aspect. This is active. So the huge landslide could be possible to transport sediments episodically to Japan Trench here. And another important point is you can see this really zigzag line of the coastline northeast Japan. This is one of the most common important concepts of being tectonically being south-sided. So geologists or village people here, they know well tectonic substance for the last 1,000 or 2,000 years. So never rebound, never come up. Some geologists, the seismologists say, oh, you can see, okay, this subsided region will come up soon. No, never. So village people here is more excellent than Japanese geologists. Okay, origin of tsunami. So collapse of huge sedimentary basins. This is episodic controlled by flow-up of sedimentary rocks in the basin. Once 1,000 years. And episodic activity of spray fault triggered huge submarine slide. So this is a genesis for the field geologists, genesis of trench turbidites commonly seen on dam in Japan now, much older, Paleozoic and Mesozoic. So question to doubt the current interpretation. No support of theoretical and observational facts of rebound against rebound theory. Lithosphere is rigid, brittle, and often destroyed, not rubber. Second, overriding lithosphere is always destroyed, fragmented, and transported into the earth by descending slab. I will discuss those sediments will go down to the bottom of the upper mantle tomorrow. Third, marine geophysics, common occurrence of tectonic erosion instead of formation of accretionary complex. And so many people now start to realize. Fourth, ubiquitous occurrence of shipwreck faults between arc-range gap, slope break point. This is a point along which earthquakes happen episodically. So let's examine the above scenario by the observed facts. I am not specialist. I cannot collect data by myself. But important key points, and I will summarize. So did the Earth Tohoku earthquakes occur along Benio plane or along spray fault? This is very, very important key question, but difficult to determine. Somebody said yes, somebody said no. And did the tsunami begin a north-south trending line source of tsunami or not? This is important, but so as I see, seems to be spot origin supporting submarine slide. But somebody say, or the other say combination. So not yet completely decided. Finally, did we observe a huge submarine landslide deposit on Japan Trench? This is the most important part. Now the people try to understand. Yes, seems to be yes to me, but need more works. So if what I said are true, then we can control tsunami disaster. I would like to discuss a possibility for Southwest Japan. First, structure of arc-range gap in Southwest Japan arc. Second, degree of development of sedimentary basin in Tohoku region. Third, tsunami disaster can be controlled by designing gravitationally unstable sedimentary basins, supplied always by rivers from land side. Four, if so, we can escape from tsunami disaster. First, let me explain the topography of Southwest Japan. Rain transports sediment into 1, 2, 3, 4 different regions. It's quite different from Northeast Japan. So exit was only one in the case of Northeast Japan, but in Southwest Japan, 4 different regions. Second, vertical elevation is also must be smaller than that of Northeast Japan. And the third, these two differences indicate first frequency and magnitude of tsunami disaster, smaller in Southwest Japan, less dangerous, but already started in a small scale off-key peninsula here by tsunami, by Kimura. So 1, 2, 3, 4 different basins and solid line with black piece. This is a distribution of spray fault zone. This is dangerous one. To stop sedimentary debris up to here to make 4 independent sedimentary basins called quark basin. So next one is a cross section of peninsula. As you can see, quark basin deposit left hand side. It's a flat sediments, and then slope break point here by the upwelling regional metamorphic belts along spray faults start from about 10 kilometer depth. And another one could be here underneath, although I didn't clearly write on this figure. But the important point is that these unstable points and pushed by much thicker sediments from land side may collapse by the trigger of earthquakes along spray fault 1 or spray fault 2. Okay, how to protect the tsunami disaster? That's simple already, you can imagine. Just gravitational instability of sediment is a key. Just danger increase through time by raining, erosion, and the transportation of sediment to these basins. So that therefore, overhaul submarine canyons and maintenance to keep empty in basin. This is the key, and it costs not so much to stop submarine landslide. Okay, probably I should stop. Okay, right, time is not enough. Okay, so conclusion first is the Tohoku earthquakes occurred along the spray fault, I hope. As a typical type of tectonic erosion type earthquakes, this is now ongoing everywhere over the world along subduction zone. Second, related tsunami was triggered by collapse of gravitationally unstable quark basin and submarine landslide for the tsunami wave, probably spot source. Third, tsunami hazard hence can be controlled by overhaul submarine canyon and maintenance of empty basins. Thank you very much.
Thank you very much. Questions?
I had been researching somewhat the tectonic erosion as a possible mechanism for the landslides that have been modeling, but I think in addition to all the evidence on co-seismic seafloor deformation, there is a problem with your scenario that only landslides would cause a tsunami. It has to do with the waves generated. Landslides have size that are such that they generate shorter waves, which here we observe both longer waves and shorter waves. So I think this points at a mixed mechanism where you have the traditional co-seismic seafloor deformation that causes a long wave. So when you look at all the evidence, not just the geology, in this case, to me clearly there were some small-scale seafloor movements which can be landslides, therefore the combination of both. But the main mechanism here, because of the waves observed and then all the evidence from seismic erosion and everything, had to be the seismic seafloor.
So you prefer the rebound model?
The mixed model, the two together.
Mixed, but you disturb one by rebound.
I'm not sure what you call by rebound, but all the observations we just heard about the gravitational anomalies and so forth. I mean, there was clearly rebound and permanent deformation on a large scale, and those are.
But final observation is just they have measured just the run-out sediments increase.
Maybe we can complete this discussion. There's one more question in the back. Wait.
That's very nice, interesting idea. But you must pay attention that most of the aftershocks of the huge earthquake occur along the surface level boundary, not the super fault. Okay. And that's very strong evidence against your point.
That's fine. Super fault is fine. But the aftershock seismicity could be here because this is a new plate boundary. Just before that, it's connected tightly together. So therefore, this one was broken. And
we
then
do find some other shocks occur along super fault, but I don't think the super fault is so well developed. Okay, and also the
I mean it's just there.
Okay.
Then after that's fine.
Okay, but anyway, you must pay attention to the aftershock distribution. Okay, also all afterfall shocks occur along the boundary, not the super fault.
There's a discussion tonight about this session, so maybe we can postpone all the other questions to then.